Hello, Leiden geometry students. Today, we're going to continue our work on things you learned from Algebra 1 that you need in geometry. And the thing we're talking about today is what's called systems of equations. A system of equations is where you have two equations, and instead of just trying to solve for x, you're trying to solve for two variables. In this case, we need to find out what is x and what is y. Now, people's first instinct a lot of times is to guess and check, but that doesn't really work. So we picked a nice easy number to work with, like say I picked 5 for x. I'm going to throw 5 in here. So 2 times 5 is 10. 10 plus 1 is 11. So if x is 5, then y is 11. But if I put 5 into the second equation, 3 times 5 is 15, minus 2 would be 13, I don't get the same answer. In fact, there's only one set of numbers, one pair of numbers for x and y that works this equation. Out of all the millions and billions and actually infinite number of numbers, only one pair of numbers works for this system of equations. So guessing and checking really doesn't help, even if the numbers are nice. It's impossible if the numbers are going to end up being decimals. So we're going to talk about our ways of solving systems of equations. The first way we have for solving, the first way you probably learned in Algebra 1, is by graphing. And graphing works based on this idea. We're going to graph both of the equations and basically ask ourselves this question. Here's a map of part of Chicago on the west side. If one person's driving down Grand Street and then this other person's going to drive up Hamlin, what's the one place they both drive through? And it's this corner, Grand and Hamlin. Well, the same idea for solving a system of equations. What we'll end up doing is we're going to graph both of our equations and look for the place that is on both of their lines. Now I'm going to do this problem, and I'm going to ask you to do one just like it next. All right, so what we're going to do for this problem is we graph both of the equations and look for the one point that's going to be on both of them. So I'm going to start with the red one, and you learn many different ways to graph in Algebra 1. I'm just going to use some points. If I find 3 points in a line and draw on the line, this line represents the red equation, y equals 2x minus 1. Again, the y-intercept is -1, the slope is 2. And then I'm going to graph the blue equation, get a few points for that one, and graph that line. And what I'm looking for is the one place where the two lines touch. Should be fairly obvious. That's this point up here. And you can find the coordinates for that point. 1, 2, 3, 1, 2, 3, 4, 5. It's at x equals 3 and y equals 5. The solution for this is 3, 5. If you plug in 3 to either of these equations, you'll get 5 for y in both of them. So you guys are going to try to solve this system of equations. You can use Desmos, or if you have some other way of graphing, go right ahead. But if you want to go to Desmos, click Graphing Calculator. Graph both of these equations. Find the point that's on both of them, and that will be your solution. Do that now. Okay, so the solution is 4, -2. These two lines touch at 4, -2. There are a few small tricks to graphing that don't come up very often in geometry, but every once in a while, I suppose. If you graph two lines and they're parallel, that they're not going to touch, not just on the screen, but would never touch each other. The two lines are so different they cannot touch, they have the same slope, then there's no solution. That means there's no set of numbers that will work in both of them. If instead you graph one line, and then you graph the other line, and they're right on top of each other, they're touching everywhere, there are infinitely many solutions. Essentially, they're both really the same equation. So we can say that's infinitely many solutions. Problems we run into in geometry will typically have one solution with a set of coordinates for the answer. Right. So if the lines touch at one point, that's our normal solution. This is the normal problem. If they don't touch at all, there's no solution. If they end up being the same line, there are infinitely many solutions. Okay, when we solve a system by graphing, there's some good things and bad things. The good is that it's easy, especially if you're doing it on the computer. It's really easy to solve a system by graphing. The bad part is, if you're doing it by hand, graphing can take a lot of time, and both by hand and on the computer, sometimes it's inaccurate. Like we saw before when we talked about quadratics with a graph, it's hard to tell the difference between 3.1 and 3.2, or any other two very close numbers. So accuracy can sometimes be a problem when graphing to solve a system of equations. Next, we're going to talk about solving a system of equations by substitution. Substitution is basically this problem from 7th grade. If you had the problem that said evaluate well, I should say expression, bad bone. Evaluate the expression 3x minus 6 if x. There we go, fixed. So in a problem like this, what this means is we're going to take 4 and plug it in for x. If x is 4, then this x can be the number 4. We take this part, this value, and plug it into this expression. So it becomes 3 times 4 minus 6. 3 times 4 is 12. 12 minus 6 is 6. So we've evaluated by substituting 4 in for x. Solving a system of equations is almost the same thing, except instead of plugging in a number, we're going to plug a whole expression in for one of the variables. And it will look something like this. Here we have a system of equations, 2 equations with 2 variables, an x and a y. Now this works best when one of the variables is already solved for. This one has that. It says y equals 2x minus 12. If you want to use substitution and it doesn't have one of the variables solved for, you'd have to take that extra step. But in this case, since y equals 2x minus 12, I'm just going to plug 2x minus 12 into y. So this first equation, instead of being 2x plus 3y equals 4, it's going to be 2x plus 3 times this whole thing instead of y. 3 times 2x minus 12 is equal to 4. And we solve this problem conventionally. You do have to make sure you include the parentheses because we're going to have to distribute this 3. So we distribute the 3 in here. 3 times 2x is 6x. 3 times minus 12 is negative 36. Then we got to combine our like terms. 2x plus 6x is 8. Then we're going to add 36 to both sides. And then divide by 8 and get 5. But unfortunately, the problem's still not done. As we know from when we graphed, our answer is 2 numbers, an x value and a y value. We only figured out x. We still have to figure out y. The way you do that is you have to take this answer for x and plug it back into one of the equations. Which one? Doesn't matter. Whichever one's easier. In my opinion, if one of them is solved for a variable, that's going to be the easier one. So I'm going to take the 5 and plug it in for x up here. So this equation, y equals 2x minus 12, I'm going to put the 5 in for x. Y equals 2 times 5 minus 12. 2 times 5 is 10. 10 minus 12 is negative 2. So our solution to this system is 5 comma negative 2. You're going to do a problem just like this with these 2 equations. So this is your problem. You're going to take this entire expression, the 2x minus 6, and plug it in for y. This is going to go in over there. You rewrite this equation, you'll have to distribute the 2, combine your like terms, and solve for x. Then once you solve for x, you'll have to plug it back in to solve for y. You can rewind the video to re-look at the example and follow the same steps for this problem. Do that now. Okay, if you've done it, our equation instead of x plus 2y equals 3 is now x plus 2 times this whole mess is equal to 3. We have to distribute the 2, and now we have x plus 4x minus 32 is equal to 3. We combine our like terms, now we have 5x minus 32 is equal to 3. Then we add 32 to both sides and subtract or divide by 5, and we'll get 7. 7 is the x value. If you didn't do it yet, figure out the y value. Okay, so we're going to plug 7 in to one of these equations, either one. The one on the right here looks easier, to find out the value of y. So I'm going to take this equation, y equals 2x minus 16, and x is going to become the number 7. Y equals 2 times 7 minus 16. Well, 2 times 7 is 14, and 14 minus 16 is negative 2. So our solution to this system of equations, x is 7 and y is negative 2. The good and bad of solving systems by substitution. The good is that it works. It always kind of works. You're not worried about not being able to read the specific point in the graph. The bad part is there's a lot of steps. But if you're good with the algebra, you're not somebody who loses a lot of negative signs, this is a good way to do these problems. It is not the fastest or the way that a real expert in math would choose. That is coming next. If you asked your math teacher or somebody else who's very good at math how they would solve a system of equations, they would pick this. It's called linear combination or Gaussian elimination or just elimination. But the thing about this is it's not hard, it's weird. The steps are much shorter than solving by substitution, and it's more accurate than graphing, but the way we get to the answer is a little odd. The way we solve by linear combination has to do with this problem. If you go to a restaurant and someone orders 3 burgers and a Coke, it costs $5.42. Someone else orders 2 burgers and a Coke, and it costs $3.92. This is enough information to figure out how much a burger costs and how much a Coke costs. If you look at the 2 meals, 3 burgers and a Coke versus 2 burgers and a Coke, the only difference is 1 burger. So the difference in price must be 1 burger. So if you subtract these, you get the cost of a burger. If you know the cost of 1 burger, you can figure out the cost of a Coke as well. Now, we're going to turn that into the math version of this, where I'm going to take this information and turn it into an equation. 3 burgers plus 1 Coke is $5.42. 3B plus 1C equals 5.42. 2B plus 1C is 3.92. That's 2 burgers and a Coke is 3.92. Now, if these 2 equations are part of the same system, in other words, your same price for burgers and a Coke, you can solve this by combining the equations. Essentially what we did is you can subtract one equation from the other, and it's still true. We still have the same values for the burger and the Coke. See, 3 burgers minus 2 burgers is 1 burger. Coke minus a Coke is no Cokes. And 5.42 minus 3.92 is $1.50. 1B plus 0C is 1.50. In other words, 1 burger costs $1.50. And then we can plug this back in and like we have in the other problems to find the cost of a Coke. But the main thing to take away here is if 2 equations are part of the same system and they're written in the same order, we'll get to that in a second, you can simply add and subtract the equations and you still have the same values for the variables. By the way, a Coke costs 92 cents in that problem. Okay, in order to do this, our equations have to be lined up. If we have these 2 equations, 3x plus y equals 19 and y equals 5x minus 12, I cannot add or subtract these. They have to be written in the same order. I'd have to have x above x, y above y, the equals above the equals, and a number above the number. So we'd have to rearrange the equations so they match. In this case, I could simply subtract 3x from both sides, and this top equation will become y equals negative 3x plus 19. The bottom one, y equals 5x minus 12. Now, y above y equals above equals, x above x, number above number. Now we can simply add or subtract these equations if we want. Now I'm going to do an example problem here. This one listed as number 1 on the left, and I'm going to ask you to do the other problem, number 2, here on the right. We'll do this twice, once for an easy pair of problems and once for a hard pair of problems. Okay, if I look at the first system here, we're looking for what can cancel out. What do we have the same of? In the burger and Coke analogy, we had the same number of Cokes, so we could subtract the equations. In this case, we have the same number of y's. We have 2y in the top equation and 2y in the bottom equation. We can simply subtract these equations from each other and make these 2 y's go away. So I'm going to subtract one equation from the other. 5x plus 2y equals 29 minus 3x plus 2y equals 19. 5x minus 3x is 2x. 2y minus 2y, those cancel out. That's the whole point. We're trying to make something cancel out. And 29 minus 19 is 10. So after subtracting these equations, we simply have 2x is equal to 10. If we solve this equation, we know what x is. So we simply divide by 2, and x is equal to 5. Once we know what x is, we can plug that back into one of the equations. It doesn't matter which one, whichever one looks easier to you. Plug that back into one of them and figure out what y is. Here, I'm going to take the bottom equation. 3 times, instead of x, I'm going to put 5. 3 times 5 plus 2y is equal to 19. So 3 times 5 is 10. Or sorry, it's 15. So 15 plus 2y is 19. If we subtract 15 from both sides, we get 2y is equal to 4. Divide by 2, we get y equals 2. So the solution of this system of equations is 5, 2. You guys are going to try to solve this system of equations. So the first step, what can you get to cancel out? Should you add the equations or subtract them to make them cancel out? Take a few moments and try to figure out the first few steps in this problem. Okay, what we have that's the same, we have the same number of x's in both. So I can simply subtract those x's to make those cancel out. And all right, I'll jump to the answer. Actually, I put that up. If we subtract the equations, the x's will cancel out. 4y minus negative 2y. It's a double negative that becomes a plus. So that's 6y is equal to negative 4 minus 14 is now negative 18. We divide by 6 and we get y is negative 3. If you take negative 3 and plug it back into either of these equations, you'll get 8 for x. So the solution of this system of equations is 8 comma negative 3. Okay, the last set here are hard problems. I will do the one on the left, and I'm going to ask you to do the one on the right. And the first thing you'll notice is nothing is ready to cancel out in this system. So I can't simply subtract these equations. 5x minus 2x would be 3x, and 4y minus negative 2y would become 6y. If we tried adding the equations, we'll get 7x and 2y. Nothing's canceling out. So what we're going to do is we're going to change one of the equations. And the way we change it is essentially, in the burger and Coke analogy, I'm going to order 2 Happy Meals. I'm going to take this bottom equation, instead of getting 2 Cokes and 2 fries for $8, I'm going to order that twice. So I'm going to take this equation to get the y's to cancel out. I'm going to multiply the entire bottom equation by 2. The whole equation, I'm going to distribute 2 times every part of this equation. 2 times 2x, 2 times 2y, 2 times 8. If we do that, now the bottom equation says 4x minus 4y is equal to 16. The top equation we didn't change, but now we have 4y in both of the equations. Actually, positive 4y in one and negative 4y in the other. If I want them to cancel out, now that we have the same number, we can simply add these equations. 4y plus negative 4y will be 0y. If I subtracted, we'd end up with 8y instead. So you have to pick addition or subtraction. So in this case, we're going to add these equations, put a big plus sign between them. 5x plus 4x is 9x. 56 and 16 is 72. So 9x is equal to 72. Divide by 9, and we get x is equal to 8. Then, like every other problem, we have to plug 8 back in for x into one of the equations to see what y is. Take a second and do that now. Okay, if you do that correctly, y should turn out to be 4. So the solution to this system of equations is 8 comma 4. Now you're going to do the problem here on the right, listed as number 5. Now the x's and the y's, they don't have the same thing. We don't have anything ready to cancel out, so you're going to have to change one of these equations. In this case, you're going to want to multiply, you're going to want to try to get the x's to cancel out. So you're going to figure out what to multiply, which equation and what to multiply by, so you have the same number of x's. When you do this right, you are going to have to subtract these equations to solve it. Start this problem now. You're going to solve for y first, so find the value for y. Okay, to do this problem right, here it is, we're going to take the top equation, there it is, and multiply by 2, and we get 10x minus 4y is equal to 50. Leave the bottom equation alone, 10x plus 3y is equal to 15. We now have 10x in both equations, so we can simply subtract them. Negative 4y minus 3y gives us negative 7y, and 50 minus 15 is 35. So negative 7y is equal to 35. We divide by negative 7 and get y is equal to negative 5. Once we know that, we can plug negative 5 back into one of the equations and solve for x. X will turn out to be 3. So the solution to this system of equations is 3 comma negative 5.